In this case, we're going to be using Gemini CLI to write a Python Pulsar function, zip it up, deploy it to a StreamNative cluster, and also test it out. So I've already installed Gemini CLI here in my terminal, and I'm using IntelliJ here. I've actually cloned the Pulsar repo, and then we're going to be working in the Pulsar Functions Python examples. These are all simple Python examples, but I'm going to actually create one that's a little bit more complicated that has a requirements file. So first off, let me show you what version of Gemini I'm using. Gemini CLI. Just so you know, it's 0.1.13, and then I'm going to go ahead and start it up. And it's going to say that there's a markdown file and an MCP server. I'm not going to show you how to set up the StreamNative MCP server or how to add it into Gemini. There's plenty of documentation on both of those. But what I do want to show is that when I hit Control-T, as it suggests to do, to view it, actually let me scroll up here and do a Control-T. Oh, actually here, it's got a list of all of the functions that it's able to see from the MCP server. And then this Gemini markdown file is kind of like a cursor rules file. It's going to guide our assistant through the process that we want to use. And I've given it a definition that I want to go through a 4-step process where we create the function, compress the function, deploy it, and test it. And then I have specific directions for each of those. So for instance, when creating the function, use this folder structure. If you have to import any libraries, use a requirements file. When you compress it, how to zip the file. When you deploy it, how to reference the file path, how to reference the class name, and then how to test it. How to set up a subscription in here. Also things like how to check the logs if it's not working as expected. So it's really going to help us through that process. So let me paste in the prompt that I'm going to be using in this example. And the prompt is to create a new Python Pulsar function called myWeatherFunction in that folder that I just described that takes a city as a string input from the topic weather input and use the free API from OpenWeatherMap and output the weather to the topic weather output. I'll edit the Python code to include the API key myself. So let me go ahead and enter that, and let's see how Gemini CLI is able to handle this task of writing the code, compressing, deploying, and testing. So if I scroll up, it's actually going to have, that's from the previous command. It's actually going to have a plan. So it's going to create the directories here. It's going to create the requirements file and then create the Python. So it's just doing the plan for the first section, it looks like, so for now. So it says, I'll proceed with creating the necessary directory. So make the directory source and dependencies and put those inside of the myWeather function. And I think it's actually going to fail because make directory is not going to, it's not going to work because it needs a complete path. So we're going to let it do it because this has nothing to do with StreamNative in this particular case. Create the directory now, create the requirements text, error file path must be absolute. So it figured out its own problem and it's going to fix it. So I'm going to say it's going to try and create that requirements file now. And then it's going to make the myWeather function Python file. We're finding the path specifications. Here it's actually got the code it's going to write. So I'll say yes, allow once. And I think that's going to finish up everything for that folder. You can edit the file. It says the location, and it tells me to add that API key. So in IntelliJ, it doesn't show up right away. I have to click in here, and once I do that, then it kind of updates this tree. And it put the dependencies folder in there, which is empty right now, the source folder, and the requirements. So here's the requirements file. Here's the Python file. I'm not going to go through the details of it, but I am going to just paste in my API key. And I went ahead and closed it so you can't see the API key. And it says that I can proceed with the next step, which is to compress the function to a zip file and deploy it. So let me say, let's zip up the file. So that's step 2. And here it says it wants to zip up the entire folder myWeather function, which is exactly what we want. In the past, I've accidentally just zipped up the dependencies source folder and the requirements txt, but not have the parent folder. That's a structure that won't work with the StreamNative cluster. When it unzips it and tries to deploy the function, it actually needs the full folder zipped up. And here it made the folder, the requirements, dependencies, source, and source with the Python code. And it already went on to the next step. It says now to deploy the function, I need to know the cluster, tenant, and namespace. Of course, it's asking for those because I have those in my markdown file. So the first MCP server call now, so this is the first time we're interacting with the StreamNative cluster, is SN Cloud Context Available Cluster. So it's going to reach out to the cluster and figure out what, or reach out to StreamNative and figure out what clusters are available in the org that I'm connected to. So there's 4 clusters, and I want to use the train cluster. So that would be, let's find that. It's this one right here, instance, and here's the name, and the display name is train. So I'm going to say, let's use the train cluster. And what it's probably going to do right away is because it knows that we next need to figure out the tenant and namespace. Actually, first it's going to say use context. So that sets it so the MCP server uses that context. Then it's going to probably ask for what is my tenant that I want to use. And it's going to list, it needs to list the tenant. So the resource is tenant, operation is list. And yes, that is what I want it to be able to do. Here it lists out all the tenants. This is a training cluster, so I have a lot of students who use this. I'm going to say, let's use the public tenant. And then once it knows that, it immediately knows that the next step is to use or check for namespace. So it sees 3 namespaces, and I'm going to say use the default namespace. At that point, it has everything it needs to deploy, so it's probably going to try and deploy the function. And there it does Pulsar admin functions, class name. This is the create command. I can't see the entire command, but yes, this is the one I want. Let me actually say no. And I'll say, can you show me the entire create command for the function? Because I can't quite see it. I'm not sure if there's a way to open it in CLI. I'm not too familiar with Gemini CLI. So actually it was nice here. It actually printed out the whole thing. And it's going to be the functions create command in public default. That's the name that it's going to use, the friendly name that's going to be in the UI in StreamNative. The full path to the Python or to the zip file. I've specified in my markdown file that you have to use the full path, the class name, and the input and output topic. So it knew to put them inside of public default. And I'll say, let's deploy the function using this command. And I'll go ahead and deploy it. And it takes about 30 seconds, probably a little bit less for it to start up. So it says, would you like me to check the status of the function to ensure it's running correctly? If I check it right now, it's probably going to say that it's not ready because it hasn't quite started up. So I'll wait a few more seconds, and that's probably been long enough. Let's go ahead and say yes. Let's go ahead and check it. And once the status is good, then we will go ahead and start testing it. So if I look up here, it says status running true. It says the function is running successfully as one instance is in a running state. I'll say yes, let's test the function. This should write a input string or string message to the input topic. It decided not to use a city or decided to not pick a city. So let's say you can choose a fun city. Let's see what it defines as fun. It says Las Vegas is going to be a lot of fun. So I think everyone has their own opinions of how fun Vegas is, but it says that's what it shows as a fun city. So it produced the message. Let's use consume. I specifically say in the markdown file to use an initial position of earliest. If you know how Pulsar works, the initial position, since we had no subscription in place at the time we wrote to the function, and hopefully the function wrote to the output topic, there's always a small chance that that message would get deleted because there's no message retention in place and no subscription yet. But in this case, hopefully that it'll still catch it. And then once we have that subscription in place, any subsequent messages would for sure get consumed. So I put in that initial position of earliest, and we'll see if it's able to pick the output message and confirm that the function is working. And it looks like I was able to get the weather back from Las Vegas. Here it says that the temperature in Kelvin is 311. It looks like I'm using the Gemini free model, Actually, I suggest if for anyone, you can use Gemini. It actually has, I've gone through this a couple times today already, and it has a great free tier, and then it goes into this other automatically switching to Gemini Flash for the remainder of the session. So let me actually go through this again. I think it failed to summarize the data back to me. So I'll say, let's consume the message from the topic again using a new subscription with a initial position of earliest. So it should be able to pick up the message again, and then we'll be able to see it summarize now that it's using a different model. So that's actually a good example. Gemini has a great free tier and then automatically switches to a different model when you run out of the free tier. And it looks like it's not going to summarize it for me any differently than what it just got straight back from the Pulsar client consume. But you can see that it did output the data into that weather output topic, and we are able to read it here. When we're all done, what we can do is we can delete the function, and also right here inside of Gemini CLI, we can also delete the input and output topics. So there it went ahead and deleted the function, and then I'll just finish up by saying delete the input and output topics. And I hope that this is able to show you that there's other tools, or basically any of the AI assistant tools that have the ability to have some sort of cursor rules or Gemini markdown file, as well as having access to MCP servers. You can then have it access the StreamNative MCP server. This can automate your workflow of creating, deploying, creating, zipping up, deploying, and testing your Python Pulsar functions. So I'll go ahead and say one more time here, and it deleted the output topics. We've actually deleted our resources, and I hope this gets you interested more in using AI assistance for coding of your Pulsar functions.